Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, the birth of graph intelligence platforms with Greg Steck, Senior Solution Architect at Katana Graph. Greg, welcome to the show.
Thanks, Darren. Happy to be here.
Hey, Greg, tell me a little bit about yourself. We've already talked to Hattie about the benefits of graph databases, but tell me a little bit about yourself and your background.
Sure. Yeah, so my background is in financial services. So I started my career at an investment bank in credit risk. So it was right at the time where they were starting to implement a lot of the CCAR stress testing. So got heavily involved in that. After doing that for some time, I did some consulting. We did more kind of credit risk modeling, model validation, and that's kind of where I was introduced to graphs, right? And really how they could be leveraged for a lot of different kinds of analysis. So a lot of benefits on the data management side, but then also on the machine learning and credit modeling side specifically. So then I found my way to Katana, and that's how I ended up here.
All right, so you're the one that made it so I couldn't get a loan on my house. Is that what I'm hearing?
Exactly.
You're the credit guy?
That's pretty much it. Yeah, you got it.
Oh, great. So you know how all those algorithms work. So you know how to work, work getting loans and things, right?
Yep. Yeah, that's what we did a lot of it. Yeah, in consulting at Goldman, at the investment bank, it was more kind of on the derivatives and OTC side, so more counterparty risk. But yeah, at consulting, we did a lot of the consumer lending. Mm-hmm.
Wow, that's incredible. All right, so what takes you from financial into something high tech, kind of bleeding edge like Katana Graph? What made you move over there?
Yeah, so when we were working with this data, as a data analyst and as a data scientist, we were constantly struggling trying to integrate all these different data sets, right? And so when I was introduced to Graph, and I was actually introduced through RDF, right? So that's like a very semantic kind of knowledge graph format. It made a lot of intuitive sense on how this data could be combined, right? So I was very familiar with the data. So it just made a lot of sense to structure it as a graph. So that's really kind of what drew me in to start using graphs.
Wow, that's incredible. And then, you must have liked it so much that you jumped ship onto creating it. Katana Graph, that's what they do, right?
Yeah, exactly. Yeah, so with Katana Graph, it was really seeing this, and we were experiencing these scalability problems, right? We were trying to use existing graph solutions. We were having a lot of, our data was very big, and we were having a hard time scaling our solutions with the existing databases. And so that's really what was, very compelling with Katana Graph was, their ability to scale, but then also the focus on, machine learning.
All right, so tell me a little bit. We mentioned at the top of the show, this is the birth of graph intelligence platforms. What in the world because we heard about graph databases. All right, they're super cool. I like using them for my work, but I can only carry those so far. So what's this next phase? What would you call this?
Yeah, exactly. So yeah, we've seen kind of the graph databases evolve over time, right? So kind of at the beginning, kind of the 1.0 was, you have the large companies like Facebook and Amazon building basically in-house their own graph databases, right? And they're doing a lot of the, the modeling and the machine learning around it. And then you had some platforms like Neo4j, Tiger Graph introduce, kind of a consumer version, right? The ability to use those for, just general use cases. But the challenge was, they really were centered around the database and not as much around the analytics and the machine learning, the processing, the graph compute. So
they were pretty limited then, because they're only, it's like a data store in that case then, right?
Yeah, exactly.
Gotcha.
Yeah, so mostly on the storage, the ingest, the CRUD operations, and not as much on the compute.
Okay. So then, that has limited use, as you were saying. So then it moves into, you said analytics comes next. Is that where you're seeing things migrate to?
Yeah, exactly. So we kind of see these in like three different kind of graph compute domains. So you've got kind of the graph query. Those are your graph database operations, right? Your CRUD operations. And then you have the second domain is graph analytics and mining. So that's where you have kind of page rank algorithms, clustering algorithms, right? Those have started to become really popular. And then the third area that we see is, graph AI and machine learning. So this is where graph neural networks really come into the picture. And there's solutions that solve, kind of there's point solutions out there that will solve, specific parts of those domains. But Katana Graph sits at the intersection of those. That's why we view that as really important.
So it's the three domains. I want to make sure I got it right. It's your graph databases, right, for your normal like storing and your normal querying type things, right?
Uh-huh.
Analytics, and then AI, and it's the convergence of all three. I mean, why do I care? Why not just stick with what's already been out there? I mean, we know the benefits of an individual graph database, but why not just convert or take snapshots of that data and put it in your traditional data lake and run analytics there? Why not just do that?
Yeah. Yeah. So what we found is that, each of these are important. Uh, you need all three of these, right, to have a successful platform. And, kind of to walk through an example, right, if you're trying to do machine learning, you need the other two domains, right? You need to be able to run graph query to prepare the graph. When you first ingest the data into a graph, there's a lot of transformations that need to be done to prepare it for machine learning. And so if you don't have this all-in-one solution, it's going to take you a lot of time for that pipeline, right? To get to the machine learning or to the analytics, it's a lot of pain to send the data out, read it back in, and there's a lot of iteration that goes on, right? You need to be able to iterate on this whole pipeline quickly.
So by going to a full graph platform, what you're telling me is I can decrease the amount of times I have to transform the data.
Yep,
That's what I'm hearing.
exactly.
Is that right?
Yeah, yep, you got it. Yeah, so we have an in-memory representation. So that's gonna, in our API, you can just operate on that same graph object through that whole life cycle. So you can ingest it, and then, we're very data scientist friendly. So, it's all Python operations that you can do just through that whole pipeline.
So that's pretty cool. So not only does that decrease time, I'm guessing that also decreases the amount of storage that you use, and also possibilities of screwing things up. Right? I mean, anytime you touch and transform data, there's an opportunity to lose data. Right?
Yeah, absolutely. Yeah, when you're trying to write back and send it between platforms and transform it, yeah, there's a lot of room for error. So yeah, and then also with our, we're a cloud native platform, so being able to separate the storage and compute, if you ever want to, pause, you can stop, save a checkpoint off for that graph, spin down the cluster, spin it back up later, and start right back off where you left it. So
Oh
there,
wait, that's really cool. So what you're telling me is I can take a snapshot of my graph in this case, right? So,
Mhm.
hey, I run into this one area that I know the next steps may be risky. I don't know what the right word is. Could corrupt my data possibly. So I
Mhm.
want to take a snapshot and keep that. So I have some temporal aspect to it, right? And then I can carry on. And then possibly if that messes things up, I can wipe that out and go back to my original. Is that part of this whole platform idea?
Yeah, absolutely. Yeah. So if you're a data scientist and you're running various experiments, yeah, you're not exactly sure what you're going to get. So you want to save a checkpoint at the beginning, try some things out, and then go back, right? But also, if you're passing it between teams, right? So in these large organizations, typically you'll have a data management team they're the ones that understand the source data. They're the ones that are going to build the graph for you, right? So they could build a graph in our platform, save it off, and then the data science team, they can pick it right up from that point.
Give me a use case. Show me how I would use this whole platform with one of your customers. Yeah, maybe someone that you've helped recently.
Yeah, sure. So we've got a great demo that we walk through around fraud detection. So there's this Bitcoin transaction data set, right? It's called the Elliptic Bitcoin data set, and we go through and we can ingest that data. So you have basically the way the data is structured is you have Bitcoin wallets are the nodes in the graph, and then you have the edges between those are the transactions, right? So it's a pretty simple graph. You have the wallets or these accounts, these account nodes, and then you're transferring data between the different nodes. So that's the structure, and then we're trying to basically predict if a Bitcoin wallet is fraudulent, right? In this case, it's illicit or licit. So these have been previously labeled as, for money laundering, trafficking, drug, right? Any of these kind of things, they flagged it as illicit. And so in the task, we're trying to predict with the new account that comes in if it's fraudulent or not, right? So the first step is to ingest that data into our platform. We build a graph, and then we want to do some feature preparation. So if you think about each one of these Bitcoin accounts, they have a whole set of numeric features, right? And to start the machine learning process, you need to do some set of pre-processing to that, right? You need to get it ready for machine learning. That in itself is really challenging. We have actually designed a set of APIs to address that problem, right? To quickly normalize one hot code, all these things that data scientists do to prepare their features, you can do that. So now you've got the graph ready to put into the machine learning model. And then from there, it goes into the machine learning model, you train it, right? And using graph neural networks, which I think we're going to get into in another episode, you start to learn about how to classify these accounts as fraudulent or not. So that's kind of an example of for fraud detection how you would go through that process.
So you guys offer one platform that lets a data scientist work on, and your data engineers, right, work on that whole thing from one platform instead of piecing things together. Is that the best way to think of the platform concept?
Yep, exactly. Yep, that's exactly it.
Very, very, very cool stuff. What other benefits do I get from using a platform? Besides, I heard ease of use, decrease in time.
Yeah.
What other things? What other things are there?
Yeah. So another one is total cost of ownership. So when you think about running this pipeline and you're using a large amount of data, there are certain patterns where you can actually have to leave up the whole graph database running all the time. So when you have if we take our example from before, if you have a new transaction comes in, you want to run inferencing against that data, right? And so in a lot of these cases, you have to keep up this cluster, which is very expensive, right? And you have to have it running all the time. But with the way that we design our pipelines and the way, because of the separation of storage and compute, we can easily spin up our cluster, do some batch processing beforehand, and then you can run inferencing kind of in a separate system, and we can still leverage what we generated in the graph. So this really lowers the total cost of ownership by a lot, right? You're only spinning up your cluster when you need it. You don't have to have it online all the time.
Also, that's pretty cool because I can, like you said, I mean, if you're running in the cloud, you're paying whether you're using it or not, right?
Yeah, exactly. Yeah, if you have to have it up for inferencing, you've got to have it up 24/7, and you got to have the whole data loaded.
Yeah. So that's I guess another question I have for you. How long does it take for, all right, to spin up a cluster to do my training? Is that a substantial amount of time? Because some of these graph databases are pretty large. Or does it load things dynamically as it needs them? Or does it have to load it all into memory? How does that work?
Yeah. So, in terms of actually deploying the cluster, we have a deployment method to do that. And once the cluster's up, that takes a little bit of time to get it configured. But then once it's up, you can easily stop and start it, right? But now when we talk about ingesting data, this might be getting to your point, we can at any time, when we first load, our load is very fast. And it's because we don't load all the data that we need at the beginning, right? So we have kind of a smart way to load the data. And then as you work through that pipeline, as you need certain properties on the graph, then it will actually load those. So we do have a dynamic way to load data only, only the stuff that you need.
So I don't have to load the whole thing into memory, because I know in the past when I've worked with graph databases, to get them started at the beginning, I'd have to load everything up into memory, and then I could work on it. And then as the changes came through, it stored the deltas out. But you guys, obviously you're beyond that now, right? I mean, that was probably an old clunky, Neo4j install at the time. So
Yeah.
I'm able to quickly bring things up. And obviously, if you're hammering the graph, it's going to take some time to get those nodes loaded at first, but after that, it'll be fast, right?
Yeah. Yep. Exactly. And a lot of this technology, this is kind of our core competency is in this area. So our founder, Dr. Kashat Bengali, right, and his team, this is where they focused their research for the last 10 years was around these optimizations to be able to do this in parallel and to do it very fast.
Very, very cool. Now, tell me a little bit more about on the analytics side, because there are platforms that have been out there for some time. I know the same techniques don't mean anything. Like MapReduce doesn't really apply into a graph database nearly like it does in a relational database,
Mhm.
right? Because you have to do that in order to split everything up across a cluster. But what kinds of operation? What can I do on the analytics side? Because I don't want to get into the AI side yet. We're going to do a whole nother podcast about that. But what about on the analytics side? What sorts of things can I do with a graph database? Can I do everything I normally did with my relational data? What are the limitations, and maybe what's better in graph?
Yeah, sure. So, yeah, when we talk about analytics, maybe we could talk about some of when we talk about analytics, we think about graph algorithms like PageRank and Levain. So maybe we could talk about those too. But in terms of like your generalized analytics, right, that you would want to do in a like a relational table, the real benefit that you get for doing that in a graph, uh, the first benefit is having a singular data model, right? So you probably talked a little bit about this with Hadi, but being able to, if you have 10 different data sets, right, and if you're an analyst and you're trying to figure out how do I join these together to write a query, that's very cumbersome and it's very error prone. Now, when you're using a graph, right, you have a singular model, right, that's already been predefined and built. So as an analyst, as a data analyst, if I'm just trying to do queries and trying to understand the data and run some basic analytics, it's going to be much easier, right, to do that with a graph because my data is already connected. I can intuitively see how the data is related.
Right. So do you guys have in your analytics toolbox you've given the ability to actually peruse the graph itself so I can see how things are related? Is that part of your analytics platform? Because I know some of the stuff that I write, because I'm a software engineer, and some of the things that I write, I started seeing new relationships between objects in my system that I didn't know when I first designed it, and they just pop
Hmm.
out because those two things are related. Let's connect them. So some of these they're not very well defined data schemas. Sometimes
Hmm.
is that fair to say?
Yeah, that makes sense. Yeah, and our focus, right, kind of initially is really on the data scientist kind of experience, right? So we have a Jupyter Notebook interface, but we do have some native visualizations in there where you can inspect the graph, right? You can see the graph schema, you can explore it a little bit. So we do have some capabilities around that.
Oh, that's cool. And then it sounds like you geared it specifically for data scientists. Jupyter notebooks, very common for the data scientists that are out there, which then gives you, as you mentioned before, on the data scientist side, I have that ability to write my Python scripts to bring data in or traverse the graph as I need to. Those sorts of things. Is that pretty safe to say?
Yep, exactly. Yeah, you got it. And one of the features that I really like about that we just introduced was Dask data frame importer. So Dask is a really common framework similar to Spark, right, where you can do parallel processing on data frames. And so data scientists are very used to working with these structures. And so we have a way instead of the traditional way to do this in graph databases, you have to learn a complicated mapping syntax, right, to be able to map it from relational to graph. But using this Dask data frame, the data scientists can just work with the data frames they're already used to using and then directly ingest those into Katana Graph, right? So it provides this really seamless way to get started using Katana.
So you've radically simplified things. It sounds like as far as for the data scientists.
Yeah, exactly. Yeah, they don't have to worry about learning a new syntax. They can just do data frame. They can use the data frames they're using and ingest those.
Very cool. Now, a lot of times, and this may be off subject, just tell me. But a lot of times, what I found was data scientists. And it sounds like you are one. A lot of times, it seems to me like data scientists work on a project, get it all working, get the results out, and then they move on to the next thing, and they don't really the company doesn't operationalize, is that the right word, operationalize that data,
Mhm.
um, because I got my experiment, it's done, and it's out, but I want real-time data. I want this continuous thing. Does this platform help with that, or have you guys built that in where, hey, I've got my analytics all set up now, set it out there, and then when new things come in, tell me what's changed or things like that? Is that part of a platform like this?
Yeah, absolutely. Yeah, DevOps is a big part of what we're trying to accomplish, right? And what we're trying to facilitate with our platform. So, one of the ways that we help with that is, and we can easily integrate into existing machine learning pipelines, right? And this is, I kind of alluded to this before, but when we run our machine learning, our graph neural networks, right, we can export the embeddings, right? These are the basically features we've generated from the graph, and we can send those to a downstream machine learning process. So the integration becomes a lot simpler and a lot easier to productionalize, because you're right, it's really easy to design a model, and then just it's hard to operationalize. But with the way that we configure our pipelines, it's particular with fraud detection, like we were talking about earlier. It's really easy to put that into production, right? It's going to easily plug into whatever downstream machine learning model platform you're already using.
Very, very cool. So it sounds to me like you guys have thought about that whole experience of the data ops. Is that a word? I don't
Yep,
know.
DevOps.
Everyone's,
Yep, yeah, you got it.
yeah.
Yeah, data ops,
It's like
DevOps.
data DevOps, data DevSec, data ops. It's going to be all over the place. Um,
Mhm.
so you guys have built that into your platform. So I can do the work. I can create these pipelines that can then be deployed on my live data and produce value coming out. It sounds like.
Yep, exactly. Yeah, we're working with some really common, model registry, metric tracking platforms that are open source that you can easily integrate with. So yeah, we definitely want to make it as easy as possible and as seamless as possible to plug into those existing pipelines.
Um, it sounds like, why would I ever use a relational database analytics platform anymore? I mean, you guys have
Yeah.
simplified this quite a bit. Is that what you see? Do you think that I can move away from your relational stuff? Would you ever move petabytes of relational data into a graph? Does that make sense or not? What do you think?
Yeah, I think it does. I think there's certain things when you talk about latency, right? Because we're an analytics platform, right? We're really built around kind of OLAP functionality. So certainly there'll be some things that you'll want to do, more in the online environment that you would want to have. You could have a relational database for. But yeah, absolutely for OLAP type workloads where you're running these large scale analytics and machine learning, yeah, it makes all the sense to do it in a graph database, because even if you want to do some of these other traditional machine learning uh, models, like deep neural networks and LSTM and all these things, you can still do that in our platform, right? So it's you're not excluded from using those types of models and those types of processes. You're just getting the additional benefit of the graph data management on the back end, and then also leveraging some of these graph deep learning frameworks.
Super, super cool. Um, wow, Greg, you've given us so much information. It's I think it's almost overwhelming, right? What you guys are able to do here. Where do you see 5 years from now? Where do you see these types of platforms? Do you see any additional types of things in here besides the three that you've talked about? Where do you see it moving forward?
Um, yeah, that's a good question. I think in terms of where I see it going, uh, I would envision this in some of these banks that I've worked in as kind of like the centralized repository where you're analyzing all of your customer data, for example, right? Where you've got your marketing data, your credit data. And what we found is when you run these machine learning models, you can use them for multiple purposes, right? There's a bank out there that's done, they basically ran a machine learning model. They built a machine learning model, and they use the outputs from it for both credit risk and also for fraud detection, right? So I think that's kind of the next level is being able to really generate kind of the 360 view, have it as a centralized repository, and then feed it out to the different, the different departments, the different groups, right? Whether it's marketing or credit or, what may it be, but that I think that's a big benefit.
Oh, that's really interesting because today, that would be different groups that were doing that and creating their own models from
Yeah,
that.
yeah,
So
exactly.
what
And
you're
they'd have,
saying is
mhm.
a common model, right? They could work off of a common model in this case.
Yeah, exactly. They're using siloed data sets, right? There a lot of replication, a lot of duplication between the groups. It's mostly the same data with a few extra fields, but you'd be able to synchronize it all within a graph and run all of your workloads off of that.
Very, very, very cool stuff. Well, hey, Greg, thanks for coming on the show today. This has been wonderful. You've opened my eyes and hopefully our listeners' eyes as well.
Yeah, thanks, Darren. Appreciate the opportunity.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.